Hi everyone, this is Andrew from ThingsBoard. In this video tutorial we are going to develop a basic IoT application using ThingsBoard. This application will collect temperature readings from multiple devices in the building. We are going to visualize these devices within the building with the ability to drill down to a particular dashboard. In addition, we will configure ThingsBoard to raise alarms when the temperature readings exceed a certain threshold. At the end of this video, we will configure ThingsBoard to send notifications about new alarms via email. Let's proceed to the hands-on part. First, we need to have an access to ThingsBoard server instance. You can run ThingsBoard in a standalone or cluster mode, either deployed on premises or in the cloud. A link to the ThingsBoard installation guide is provided in the video description. However, in this tutorial we will use a live demo server deployed in the cloud to simplify the getting started process. You will need to complete a simple sign-up procedure that should take a minute or two. Once you submit the form, you will receive an email with the login details. It is totally free. I am going to use my existing account right now. We have just logged in using Tenant Administrator role. The tenant administrator is able to provision customers, assets, and devices. First of all, we will create a building asset. So let's navigate to the Assets panel and click on the plus icon on the bottom right corner of the screen. I'm going to fill in the form with the building name and type. Please note that you can populate any asset type and it will be automatically created for the future use. So now, after we have created our building asset, we will create some devices. I am going to create two thermometer devices. These devices will be used to collect temperature readings in different parts of the building. Now let's go back to the assets and create relations. Relations from the building asset to the thermometer devices. These relations are heavily used by ThingsBoard in multiple cases and will help us to build the navigation in the dashboard. Relations are highly useful when you have a lot of buildings and a lot of devices. You basically define a graph. The node of this graph are the ThingsBoard entities, and the edges of this graph are ThingsBoard relations. As you can see, ThingsBoard data modeling is quite simple and powerful simultaneously. It allows you to model the complex systems of the physical world in ThingsBoard. It's time to finally push some data from the thermometer devices to ThingsBoard. In this video tutorial, we are going to use the HTTP protocol to push the data. However, ThingsBoard also supports different protocols and connectivity technologies. You can find a link to the list of guides for specific protocols and connectivity solutions in the video description. I have opened the command prompt and now going to substitute some important values in my command. We will need to replace the hostname and the access token. You can easily copy-paste the hostname from the browser window. There is also a Copy Access Token button located in the Devices Details panel. Let's run the command. As you can see, the telemetry arrives in a few milliseconds only, due to the usage of WebSockets instead of polling. This also helps to minimize the load on the server instance. For the purpose of this tutorial, we need to set up a constant data stream from the device. Let's navigate to the rule engine and create the data generator that will emulate the physical device and send some messages on its behalf. We are going to create a new rule chain that will be responsible for emulating the temperature readings from one of our devices. You can treat the rule chain as an event processing graph. There are multiple rule nodes that you can use to implement your use cases. We will pick and configure the generator node. I'm going to give it a meaningful name and configure it to generate a new message every 10 seconds. Let's select our device and define JavaScript function to generate the new message. A link to the function code is attached in the video description. The message we are going to generate is identical to the message that is supposed to be sent from the HTTP transport. However, the only difference is that the temperature is generated randomly and the simulated messages do not impact the device connectivity state. Since the physical device is not actually sending any data, ThingsBoard will mark the device as offline. Now, when our generator is ready, it's time to stream messages from the generator to the root rule chain. The root rule chain is the one that receives all incoming messages from various transport models and from client REST API calls. It has a message type switch that helps to dispatch messages to different handlers based on the message type. In our case, the post telemetry message is pushed to the rule node that precedes the message into the database. It also notifies all WebSocket subscribers about the change. Let's navigate to the device details and ensure that the rule chains are working properly. We should see the new temperature data arriving in the last telemetry panel every 10 seconds. As you can see, the device emulator works fine, and it's time to create the dashboard to visualize our data. Let's navigate to the Dashboards panel and create our new dashboard. We will call it Demo Dashboard. First, we are going to create entity aliases to be used by widgets. The entity aliases is basically a reference to one or multiple ThingsBoard entities. Unlike most of the solutions, ThingsBoard dashboards may have multiple states. So the value of a particular alias may change when the user switches between the states of the dashboard. The first alias I'm going to create is a list of thermometers related to our building asset. We will define the list of thermometers using device search query. This query will return all thermometer devices that have direct and bound relation from our building asset, and the relation type should be equal to contains. Once the alias is saved, we can add the entity table widget to show our devices. I'm going to locate this widget in the cards widget bundle. Now I'm going to add a data source and I will select the thermometer's alias. I'm going to type the telemetry key name as temperature. Let's also update the title of this widget. As you can see, we have two devices. Only one of them is reporting temperature, because the other ones doesn't have any emulator configured. So we have our device list available, and now it's time to add new dashboard state to enable drilling down to a particular device details. I'm going to put a specific expression to the state name in order to see the current device name when the user opens the device details state. Let's add the state and navigate to the new state. Now we need to add a new alias. We will call it current thermometer, and it will refer to the thermometer selected by the user. Note that we are using a special filter called entity from dashboard state. Let's add the digital gauge widget to show the latest temperature reading from a selected sensor. I'm going to use a new alias in the widget configuration and the same temperature key. Let's resize the widget a little bit and create another one to show the history of temperature measurements. We are going to select the flowchart widget and use the same alias and the same telemetry key. Let's resize and change the position of this widget. The last widget I'm going to add to the state is the alarms widget. We will use it to show the active alarms for each device. Let's make some configuration changes and finally save the dashboard. After saving the dashboard, we automatically get back to the default state. Now it's time for the final configuration. We need to add a row click action to the entity list widget. This will enable switching between the states when the user clicks on a particular thermometer device. Note that we select the target dashboard state in the action configuration. Let's save the dashboard and see how it works now. You can also see that we can change the time interval for the charts very easily. Our next task is to trigger alarms based on temperature readings. This is quite easy with ThingsBoard. Let's create a new rule chain and call it create alarm. I'm going to use the filter script node to filter all telemetry and compare it with 50 degrees value. Next, I'm going to add a create alarm node. I will specify the alarm type as critical temperature and alarm severity as critical. Note that I have also checked the propagate flag checkbox. This means any alarm that will be generated on a device level will be automatically propagated to the parent asset levels. This is very useful if you want to keep track of all active alarms on the parent level. The final configuration step here is to make the relation between the script node and the create alarm node. Let's jump to the root rule chain and forward all incoming telemetry to our new rule chain. Note that in a real-world scenario, you should apply some filtering to the incoming telemetry values. For example, there is no sense to forward any humidity readings to the rule chain that process temperature readings. In order to do this, you can use many available filtering rule nodes. You can also review other ThingsBoard rule engine guides using the link attached to the video description. Let's navigate back to the dashboard and push some temperature readings from the command line to trigger the alarm. As you can see, the alarm is created successfully and it is in active unacknowledged state. The alarm may be either active or cleared. In case the device will send the high temperature reading again, ThingsBoard will update the existing alarm. Once the alarm is cleared, a new alarm will be created in case of new high temperature event. We will show how to manually clear the alarm later. Alarms are usually cleared automatically, for example when the temperature drops below a certain threshold. However, the cleared alarm may stay unacknowledged. This means no one reacted on the alarm. Sometimes it is okay, sometimes the alarm needs to be manually acknowledged by the operator. Now let's make a final configuration step in this video tutorial. We will configure the rule engine to push a notification about the new alarm over email. Let's modify the create alarm rule chain. First, we are going to use the script node to add temperature from the incoming message to the message metadata. It is quite easy to manipulate the incoming message using the JavaScript functions. Now let's reassign the relations accordingly and create a new node that will transform the incoming message to the email message. I'm going to specify a meaningful name, an email address to send the email, and tune the email body template to show the actual value of the telemetry. Let's save the rule node and create a relation from the previous node. I'm using the relation of type created, which means that only events about the new alarms will be sent over email. If you want to receive the email on each event that exceeds the threshold, you should use the updated relation. Now let's add a send email node. Here is the most challenging part, since you need to specify the SMTP server settings. For security reasons, we have blocked the users from using our SMTP server on the demo environment. That is why you need to specify your own server. We will use our SendGrid account in this case. It is very easy to set up and they have a free trial. We will copy-paste all the settings, including the API key, as a user password. If you are using ThingsBoard installed on premises, your system administrator may already have configured the SMTP settings for you. Let's get back to the dashboard and clear the alarm. This is important because notifications will arrive only for the new alarms. I am pushing the trigger event again from my command line. Let's now open the email client and check that alarm arrived. Let's summarize what we have learned today. In just a few minutes of using ThingsBoard, we have collected and visualized data from multiple thermometers in the building. We have modeled the building as an asset. We have also modeled thermometers as devices in ThingsBoard. Finally, we have raised alarms when temperature exceeds a certain threshold and notified the user by email. Thank you for your attention. I hope this video will help you to get started with ThingsBoard. We recommend you to explore the ThingsBoard guides. We have plenty of tutorials that cover data visualization, rule engine, and also guides that help you to connect your real devices using various protocols and connectivity solutions. Please fork and start our project on GitHub. Don't forget to subscribe to our YouTube channel and to our newsletter to get the notifications about the new videos and tutorials.